Hi guys, in this video we are going to look at the process of hearing. Okay, my name is Divine Gift and this is Divine Gift Lectures. I've been newly admitted into the University of Ibadan to study medicine and surgery, and I'm doing these videos for you guys. So don't forget to subscribe, and also click the like button for this video and comment. All right, let's get into business. In today's video, we're going to be looking at the process of hearing. We've done a video on the structure of the ear, so don't forget to watch that one. Okay, so we are going to look at the process of hearing. The part of the inner ear used for hearing is called the cochlea. It's called the cochlea. We also have the other part that's used for what? Balancing. The other part of the inner ear used for balancing, that's called the vestibular system. But in today's lesson, we are going to look at what? Hearing. So we'll be concerned with the cochlea. So now we are going to draw the what? The cochlea. We'll start from the inner part of the cochlea first. Okay, so this is the inner part of the cochlea that I've drawn. The cochlea is actually much more curled, it's curled in much more, and this is actually just for simplification purposes. Okay, so now we are going to call this a labyrinth. So what's actually labyrinth? The labyrinth is a complex pathway or passageway. As I said before, this is actually much more curved, so it's actually complex, okay? And it's a complex pathway. All right. So since it's membranous, we are going to call it the membranous labyrinth. So this is the membranous labyrinth. Okay, so this is the membranous labyrinth, and as I said, this is the inner part of the cochlea. So I'm going to draw the outer part. So we have another labyrinth that encloses this membranous labyrinth. That is what I'm drawing now. So this is the outer labyrinth that actually what encloses the membranous labyrinth, and it is bony. Okay, so we are going to call it the bony labyrinth. The bony labyrinth. Okay, so this is actually what the cochlea. As I said before, it is much more curved, but this is what for simplification purposes. All right, so inside the bony labyrinth, we have a liquid called the perilymph. While inside the membranous labyrinth, we have a liquid called the endolymph. Okay, so inside the bony labyrinth, we have a liquid called the perilymph, while inside the membranous labyrinth, we have what? A liquid called what? The endolymph. And this structure inside the membranous labyrinth present in the cochlea is called the cochlear duct. Take note of that. This is called what? Cochlear duct. Okay, so that's the cochlear duct, and this whole structure that I've drawn now is the cochlea, and it's what? It is the part of the inner ear used for hearing. Okay, so we are going to look at the structure, the cross section of what? I'm going to look at the cross section of the cochlea. So we are actually going to take this diagram that's supposed to be here, and we are going to enlarge it. All right. So I'm going to draw the one I've drawn with the blue line is what? Is this structure, the membranous labyrinth, while the outer one, as I said before, is what? That encloses the membranous labyrinth is the bony labyrinth. Okay, so as I said before, the fluid here is what? Called the perilymph. Okay, the perilymph. That's the fluid contained what? In the bony labyrinth. So this fluid fills up these parts, and now we are actually going to draw what? The inner structure of what? The membranous labyrinth, which is what? The cochlear duct. And as I said before, the fluid that is present here is what? It's called the endolymph. So let's go back to drawing the inner structure of this part, that is of the cochlear duct. Okay, so now okay, so this part we are going to call it the tectorial membrane. While this part below we are going to call it the basilar membrane. Now, between the tectorial membrane and the basilar membrane, we have a group of cells that are what? Called the sensory cells. They are the sensory cells. And lastly, we have the nerve that comes out here. And this is what? The cochlear nerve. This is the part of the auditory nerve that what comes from the cochlea. Okay? The cochlear nerve what? It leads to the brain. Alright, so this part, all labeled in blue, is actually called the organ of Corti. So I'm going to label it here. The organ of Corti. Okay, so this is actually the cross section of what? Of the cochlear duct, and this of the what? Of the cochlea, and this is the shape of what? The cochlear duct. It's actually almost triangular. All right, so this is the cross section, and we are going to go over to how what hearing actually occurs. As I said in the other video, watch that one if you haven't watched it. That's on the structure of the ear. The pinna what? Collects sound waves. It does what? It collects sound waves, and it passes it through the ear canal. It passes it through the ear canal, which is this. We dealt more on the structure on the other video. We're going to draw it a little here. So when the pinna actually does what? Passes the sound wave through the ear canal, and what? It reaches the eardrum, also called the tympanic membrane. When it reaches the eardrum begins to vibrate. Okay, in the same way what? The same frequency that what the sound waves vibrate. It's going to start vibrating, and as we've seen before, we are going to see what? The ear ossicles. We're going to see that the ear ossicles also begins to move to and fro, because it's what? They are what? The first part of the ear ossicles, that's the first bone, is connected to the eardrum. So when the eardrum vibrates, the ear ossicles is also going to move to and fro. And we know that this place, that's what? Where the last part of the ear ossicles is called what? The oval window. So this one is going to vibrate. It will cause this to move to and fro, and this will also cause what? The oval window to vibrate. So the oval window is also going to begin to move to and fro, and because it has a smaller surface area than what the eardrum has, it's going to vibrate more strongly. Okay, the vibration is going to be amplified. All right, so from here we are going to what? Have the cochlea. Okay, and that's what we've drawn here. So we are just going to go over to this place, and we are going to find out that what? The oval window is actually connected to this upper part of what? The bony labyrinth. Okay, so it's going to be connected to this upper canal. That's what? Where the oval window is, and it's what? As I said before, it's vibrating. Okay, so these ear ossicles are transferred the vibration from the eardrum to the what? Oval window, and what? In the process of doing that, the vibration has been amplified. and what we are seeing that the oval window is in this place, and what it is vibrating. Okay, so when it's vibrating, it's going to move the perilymph. Okay, it's going to do what? It's going to move the perilymph through here and back to this place. And at this place, we are going to see that this place is where the round window is. Round window. So when it moves the perilymph, it also comes back here and what causes the vibration of the round window. And we must know that what this movement of the perilymph, we can also call it the pressure that we can also say that pressure waves have been set up in what the perilymph. So pressure waves have actually been set up in the perilymph. Now, not only does the perilymph move what straight in this way, but it also what moves sideways. Okay, the pressure waves are also what sideways. So it affects what this part, that's this cochlear duct. So we are going to go back to this place to see how what the hearing takes place. Okay, so as I said before, the perilymph not only moves forward, it's going to what also affect this part, all right, because what the pressure waves is going to also be laterally or what sideways. Okay, so now when the perilymph sets this pressure, has pressure waves in it, and what that's when pressure waves have been set up in the perilymph, and what it affects this part as it was, it's also occurs sideways. The basilar membrane is going to be affected also. It's elastic, so it's going to move, all right, it's going to move up and down. And when it moves against what? When it moves, you know that what these are the sensory cells, okay, and this is the tectorial membrane. Now the tectorial membrane is actually fairly stationary, okay, it's fairly stationary. So this one is going to be moving much more than what this one moves. Of course, movement of this one is caused by what the endolymph, but this is directly by what the pressure waves of this perilymph. Okay, so this one is going to move much more than this is moving, and when this causes what? When this moves, the heads of the sensory cells are going to press on what? On this tectorial membrane. And when that happens, an impulse is actually sent to what? Through the cochlear nerves towards the brain. Okay, so that's actually the process of hearing. Just explained to you. The pinna collects what? Sound waves, passes through the ear canal, then it what? It impinges, the sound waves are impinged on what? The tympanic membrane or the eardrum, also called the eardrum, and the eardrum begins to vibrate. This also causes what? The oval window, the ear ossicles, since they are connected to what? One of them is connected to the what? Eardrum, they begin to move to and fro, transferring the what? These vibrations to this part, which is the oval window, and the vibrations are also what? Amplified. Now these vibrations what? Cause pressure waves to be set up in the perilymph, and what happens from then on? The basilar membrane begins to move because of what? The pressure waves, and when it moves, the hairs of what? The sensory cells are what? Brushed against what? The tectorial membrane, and what? Impulses are what? Sent to the brain through the cochlear nerve. Alright, as I said before, the tectorial membrane is fairly stationary, and that's why what? It moves far more than this. The hairs of the sensory cells actually brush against what? This, and what? Impulses are sent to the ear. Okay, so the loudness of what? Sound can be measured in decibels. Alright, so it's also good to know that very loud sounds can affect the ear. It's not good for the ear. So very loud sounds can affect the ear. Well, when a sound can be scarcely heard, you can say it's 0 decibels. Okay, and also it is good to know that the frequency of sound that we can hear is actually in this range. Okay, 40 to 1,600 hertz. Well, sounds of higher frequency can be heard by what? Dogs and what? Other animals. Okay, and lastly, animals have what? Something known as binaural hearing, that is hearing with what, 2 ears, and that is helpful because it helps us to know the direction from which sound is coming from. I'm assuming sound is coming from this direction, it's going to reach this ear first, and the intensity is going to be much on this ear compared to this. So when I do hear it, I can know that what the direction is from this place. So that is for hearing. Like this video if you loved it, and if it taught you really well, don't forget to comment. Okay, so if you haven't subscribed, also subscribe now, and don't forget to watch more of my videos. All right, God bless. See you in my next video. Thank you.